Hey guys, today we're verifying inverses. So yesterday we talked about what inverses are and how they are a reflection over the y equals x line. So this is the y equals x line. So this is a reflection of this. Therefore, they're inverses. We just did number one like that easy. Anyway, so number one, we're just talking about if they're inverses. So first thing you do, you look for the y equals x line. And in this case, it's already graphed for you. And then you go, okay, this is my graph, and this should be the inverse. Is that a reflection across the y equals x line? The answer is yes. Therefore, they're inverses. Yes, they are inverses because they reflect across the y equals x line. And something else is if they were to intersect, they also, if they're inverses, they will intersect at the y equals x line. So they intersect on the line y equals x. Okay. So the next one, we're going to figure it out if these two equations, if these two functions are inverses of each other by graphing. So we know that if they're inverses, they reflect across the y equals x line, and also they intersect on that same line, on the y equals x line. I went ahead and already graphed the y equals x line right there for you, just so we don't waste time doing that. And now I'll go ahead and graph both of them. I will color code. I'm going to just do red for the first one. So y equals m. The slope is m. X plus b. B is the y-intercept, 2. So this is the y-axis. I will start out by plotting my y-intercept right there at 2. Rise over run. Rise 1. Run 3. 1 up, 3 over. So this is f of x. Now the other one, you can't see purple. How about light blue? Yeah, light blue on this one. So the slope is 3. The y-intercept is -2. So that's where I'm going to start graphing. Right there, the y-intercept, -2. I rise 3, run 1. 3 up, 1 over. So this is the g of x function. Okay, couple things. I know you guys were expecting f of x and g of x to intersect right there at the y equals x line. But they did not. They did not intersect at the y equals x line. Therefore, they're not inverses. So no, f of x and g of x are not inverses. They do not intersect at y equals x line. Now, we have 2 more examples, and we're going to also verify if 2 functions are inverses, algebraically this time. And to verify them algebraically, we need to do some composition of functions. So functions g of x and f of x are inverses of each other if f composed g of x equals x, and g composed x, g composed f of x is also equal x. What does that mean? Well, we did a couple days of composition functions, and this is the reason why. So leading up to this point. So if I need to determine algebraically if f of x and g of x are inverses, I need to do the composition functions. So I will try first f compose g of x. So I'm going to get the function g right here and substitute right there for x. So 2, and then I'm going to compose that. Distribute the 2. 2 times half is just 1, so 1x, minus 2 times 2 is 4, plus 4. So simplify, negative 4 plus 4 is 0, and I only have x left. So it's looking good. F composed g of x is already equal x. So now I also need to verify if g composed f of x is also equal to x. So here we go. G composed f of x. So now I have to use the g function, the g of x function. So 1 over 2. And now I will use the f of x right there to replace x. So this time, I'll get this function right here and substitute that for this x. Distribute the half right there. Half times 2 is just 1. Half times 4 is 2. Positive 2, negative 2 adds up to 0. So voila, g compose f of x equals x. And also f compose g of x also equals x. So I can conclude that f of x and g of x are inverses. Okay, one more. Now we have a cube root and a cubic function. Okay, so now we're going to determine algebraically if f of x and g of x are inverses. So f compose g of x. So I get the function, substitute that for x. So cube root of the g of x function, and then minus 6. Now the cube root and the cubic function, they simplify. So now I have x minus 4 minus 6. When I simplify this, I have x minus 10. I was expecting that to equal 0, but it doesn't. So if the first one already doesn't check, so there's no reason for me to keep doing it because they're not inverses. In order for them to be inverses, you need both. And since from the get-go, the first one already didn't give me the x, so there's no point of you to keep going and try to find g compose f of x, okay? Because this one already doesn't check. There's no point to keep going. So, since f compose g of x does not equal x, f of x and g of x are not inverses. I will see you later.